your science notebooks. You should have a pencil. You should have a ruler. If you do not have a ruler, someone in your group will have a ruler.
What if they don't? I have one.
So, we've been talking about force and motion. Okay. Do I need to have you go sit at your desk? And stand and bottom of your desk. So let's review what we know about force and motion so far. So what are some things we already know about force and motion? Sadie, what do we know?
Things in motion like to stay in motion, and things that aren't in motion like to stay in motion.
Exactly. So we know Newton's first law of motion. That things at rest like to stay at rest, and things in motion like to stay in motion unless what? Ebony. Something pushes on it or Silver? Pulls. And what do we call a push or pull? What is its scientific name?
A force.
A force. So we know that anything at rest likes to stay at rest. Kristen, this is your last warning, then you're going to sit at your desk with your head down. And anything in motion likes to stay in motion unless acted on by a force. What else do we know?
And there's a really big mass, and you aren't bigger or the same as the mass, and you pretty much can't push it. You need a bigger mass to push the mass.
So if you have something so what you're saying is if you have something with a lot of mass and a lot of weight, you need more force to get it to move.
Mm-hmm.
Okay? What else do we know? Anything else? What are some experiments that we've done? Are there things that you know more about force and motion, or experiments that we've done that have showed us some ideas about force and motion? Chloe.
We've done the landers and rovers, like we dropped them down because of the gravity could pull them down.
Okay, so we know about gravity that pulls them down, and we experimented by making landers and rovers. London.
We shot marshmallows and tried to get the egg into the glass of water with a piece of pan and a balloon.
So we looked at making catapults and seeing how much force we needed to move the mass of the marshmallow from our catapult. And we looked at inertia when we were looking at the egg and trying to get the egg into the glass of water using the pizza pan and the broom. Do you remember the special name that we called the broom? They gave it a scientific name. I don't know if you'll remember it. It's a real tricky name. It started with an F. Do you remember it, Lindsay? Or Silver? It's a tricky one.
Give me another letter. Yeah.
Maybe Oren has it. Oren, do you have it?
Friction?
Oh, we did talk about friction. You are right. But that's not the term I'm looking for. Do you remember, Lyndon?
Force?
We did work with force. It was the fulcrum. Remember we were using the fulcrum.
Yeah.
So today, we've looked at Newton's first law of motion, where we saw that things at rest like to stay at rest, things in motion like to stay in motion, unless acted on by a force. We looked at mass times acceleration, so Newton's second law. Today we're going to take a look at his third law. For every action, there's an equal and opposite reaction. And we're going to do an experiment to see how that works. Okay, and so what you're going to do is with your groups, you're going to have a baggie of stuff. And in your baggie, you have a 3x5 card. Actually, there's two in case for some reason your first one gets ripped. You have a balloon. You have a straw. You have a piece of string. You have 2 paper clips and some washers.
I know
Okay,
what
look
we're
at that way.
doing.
To be added for weights.
Yeah. I know
So,
exactly what
I'll wait for you.
That's a washer.
I'll wait for you. Yes, Marco.
What's a washer?
A washer is a piece of metal that has a hole through the middle. Sometimes you use it for building things, but we're going to use this to add weight to our card. But this is going to come in our second step. So your job is to try to make a type of rocket out of these materials. And because we know that for every action there's an equal and opposite reaction, we're going to see what happens if we can build a little mini rocket with this card, is we move our rocket along some sort of surface. Okay? So before we break apart into groups to brainstorm how we're going to build our rockets, the first thing we need to do is in our science journals, we need to put today's date and list our materials.
What's the date of today?
So today is the 27th of January, and we're going to list the materials that we have to work with. Because any good scientist should know what materials they're working with so that if someone else comes along and wants to replicate their experiment, they can. Yes, Jacob?
We're going to have 2 people in each group.
You will have, one group will have 2 people, the rest will have 3.
Yes.
So what were some of the materials I said we had in our baggies that you're going to use? Alexander, what was one of them? 2 cards.
Two cards? Oh, yeah.
Christian.
Washers.
Washers. Now if you're not writing this down, then you're not following my directions. So you need to make sure you're writing your materials down. So,
A balloon and string.
a balloon.
And yarn.
And yarn.
Paper clip.
Paper clips. And there are 2 of them.
What's a yarn?
String. Anything else? Celia.
Straw.
A straw. And there's one more thing that you're going to need that I didn't show you because it's on the back hexagon table, but that is tape.
Exactly what I need to make a rocket. I know. But you don't need it by yourself. Yeah, I know. Maybe it'll be a story. But I know.
Ooh, I love how Zoe is writing her materials down. Maya is writing her materials down. Marco has his materials. So we're practicing with Newton's 3rd law. For every action there is an equal and opposite reaction. And so you're going to, with your group, first brainstorm how you think you're going to put these materials together in order to have them move. Because we want to use force to show movement. Okay? And you're going to draw it out. You're going to have to chat about it first with your groups. Maybe draw a diagram. Right? That's our scientific name for a picture and is a diagram. So maybe draw a diagram to go along with it. Then I'm going to check it and see where you're at with your thoughts and ideas and give you some suggestions to maybe guide you in the direction that you need to go to be successful with your experiment. Yes, Jacob?
We make our rocket go like sideways.
Ooh, I think that is a fantastic idea to make your rocket go horizontal. Why are you thinking?
Because I know an exact way I learned it in the 1st grade classroom.
Mm-hmm.
And because there's like a book with and it like teaches you all about like force and motion and like how to make cool like stuff. And I have an exact idea how to make rockets out of all of those materials.
Awesome. So you're building on what you already know from something that you read. And so you're thinking, if I build on what I already know from what I read in 1st grade out of a book, that I can make a rocket that moves horizontally. And I think that's a really fantastic idea, Jacob.
Because I've never got to test it.
And I would suggest to the rest of you to try to build your rocket so that it also moves horizontally. That is a good idea, Jacob.
Like this?
Yes, horizontally like this. Left to right.
Like this.
So I've already split you apart into groups. What I'm going to do is give you about 2 to 3 minutes to plan and discuss things with your groups. Then I'm going to ring my chime and we're going to quiet our voices down. I'm going to come around and check to see where you're at with your plans, with your diagram. And then we'll start building. Okay? Once you've built your rocket, then we're going to make a hypothesis. So we'll come back together and we'll hypothesize or make a guess on what we think will happen when we use our rockets. Capiche? Okay, so when I say my magic word, you can break apart into your groups. My first group is Silver, Noelle, and Jenna. My second group is Maya and Christian. My third group is Alexander, Chloe, Scobo, and Marco. My fourth group is Caleb, Ebony, and Celia. My fifth group is Oren, Chloe Wilson, and London. And my sixth group is Jacob, Zoe, and Sadie. Oh, I have not said my magic word yet, London. Now what you can grab is you can grab your baggie of materials to take a look at them while you're building your diagram. You may not grab your tape though, you don't need it just yet. Fish? You may go. So remember, you have 2 to 3 minutes to plan and build your rockets. Diagram it out. Silver and Noelle.
No, we need to use everything. I know.
Yeah, 6 more minutes.
No. Maybe we could need to attach that.
What's your rocket gonna do?
That the bear. Yeah, there. 2, okay? Yeah, that. And then we're not gonna put them in. Just to put there. Oh, we got a long string. Then we're gonna attach. You can draw it.
What is your plan that you have?